Let's begin this video. We're going to be explaining the practice quiz 2.3, 2.4, where we're graphing and also writing equations both in slope-intercept form and point-slope form. On this section of the video, we're going to be calculating the slope, both where it's given to us on a graph by counting rise over run and also by calculating the slope using the slope formula. So let's begin with the graphs. Once again, we need to know that the slope is a fraction that tells you how steep a line is. And the steepness is measured with the rise over run. Okay. Now keep in mind that the rise, if it's going up from left to right, that's positive. If it's going down from left to right, that's negative. Now the run is always from left to right. We're always going to make that positive. Okay. So we got to look at lines the way we read sentences from left to right. And if I were you, I would pick nice coordinates, clean coordinates. What do I mean by that? Well, you see, this is not a nice coordinate. This is not a nice coordinate. This is our first nice coordinate right here. So let's put a dot right there. And let's continue to see where's the next nice coordinate, which would be up here, that perfect coordinate right there. Okay. Now, we don't have to do any algebra. All we have to do is count the rise, put it as a numerator, count the run, put it as a denominator. So from this red dot, from this nice coordinate to that nice coordinate, how much do you actually rise? You rise 1 unit. It's like altitude, right? How many units do you go up? It goes up 1 unit. So because you're going up, it's going to be a positive 1. Okay. So the slope is positive 1 over. The run is always positive as well. You always look at it from left to right. How many units do you run? You run 1, 2, 3, 4, 5. So the slope is 1/5. Okay. Be careful if this is a multiple choice option. You might have different slopes like 1/5 or 1/4. So be very careful with that. Make sure you count carefully. Click on the picture to make the picture bigger so you could actually see it better, so you could count it better. Let's move on to number 2. Same deal. State the slope. We know slope is rise over run. Okay, and you always look at it from left to right. So the run's always positive, and the rise, if it's going up, it's actually a positive rise, but if it's going down, it's a negative rise. So let's find those nice coordinates. Okay, so this actually looks like a nice coordinate, but if you're not too sure, just keep going. That's not a nice one. This is a nice one right here. I'm actually going to put a dot on that one. Then I'm going to continue to go down to the next. That's not a nice one. This is a nice one right there. So you could pick any 2 nice coordinates on your line, and then from this one, you always want to look at it from left to right, kind of like the way you read a sentence. From the left dot to the right dot, are you going up or are you going down? Obviously, you're going down, which is a negative rise. So how many units from this point on the left to the point on the right, how many units do you actually rise? Are you rising up? No, you're dropping. So that's a negative rise. So you're going down 1 unit, and you run from left to right. How many units do you run? You run 1, 2. So you're going down 1 over 2. Just to visualize it, it's going down 1 unit. So that's a negative 1 rise, and it's running 1, 2. So that's a positive 2 run. So what's your slope? Your slope is negative 1 over 2. That's your slope, negative 1/2. Let's move on to this next question. And the next question is, I don't give you a graph. And yes, you could graph it if you wanted to, but I don't recommend that, okay? It says state the slope of the line passing through these 2 points. So if you wanted to, you could graph it if you actually had graph paper and put both points and then count from one to the other how much you rise and how much you run. But I would rather you use the slope formula. And the slope formula is m equals, we already know it's rise over run. Now, what does rise actually mean? It actually means the differences in the y values. So the slope is y2 minus y1, and that's technically your rise. Okay, now the run is technically the differences in your x values. So it's going to be over x2, the second x value, minus x1, the first x value. Now this might seem a little confusing to you, but memorize this formula. Okay, you got to have it in your head. And whenever you use this formula, I recommend rewriting it without the y's and x's. And let's actually plug in the y2, the y1, the x2, and the x1. Now if you're thinking, where do I get that? Well, we have two coordinates right here. And what are coordinates? They are x values and y values, x values and y values. Now, if I said, look at x, well, you don't know if I'm looking at the first one or the second one, right? And that's exactly why we label it x1 and x2. And if I tell you, look at y's, well, which one are you talking about? Are you talking about the first y or the second y, right? That's why we label the first coordinate x1, y1, and the second coordinate x2, y2. Technically, it doesn't really matter which one you label, your first or your second, but you gotta label them, right? Anyway, now we could plug in y2, which is -3, minus y1, which is also -3, divided by x2, which is -1, divided by, or minus x1, which is 7. Okay, and what could we do? We could change the minus minus to plus plus, and then we simplify. So what is -3 plus 3? That's 0. And it's going to be divided by a -1 and a -7, that's -8. But the bottom line is 0 divided by any number is still 0. So right here, ladies and gentlemen, the answer is that the slope is 0. It has no slope. Now, what does that mean visually? If you were to actually graph this, that means that the line will be totally flat. It's not steep at all. It's like the floor, totally flat, because it has no slope. To be specific, it would have your y value of 3, and your line would be totally flat going right through that y value. I said 3, -3, I'm sorry. So it'd be a totally flat line crossing through the y-axis at -3. But you don't really have to know how to graph it. All you got to do is memorize the formula and know how to apply it, getting this answer m equals 0. You could also say no slope, but it's definitely not undefined. Undefined is a totally different thing. We'll talk about that later. Another question where we're asking for the slope given 2 points. We all know that the slope is really the rise over run, and we all know that to find the rise, you're really finding the difference in your y values, y2 minus y1, and to find the run, you're actually finding the difference in between your x values, x2 and x1. And we should all know that the coordinates are really x and y values, and the first coordinate, we're going to call it x1, y1. The second coordinate, we're going to call it x2, y2. So how do we apply the slope formula? You simply rewrite it, the division bar and the subtractions. I always do this. It'll help me, it prevents me from making mistakes, and I recommend you do it as well. Plug in your y value of y2 of 0 right here, your y1 of -3 right there, your x2 of -2 right there, and your x1 of -2 right there. And yes, the minus minus changes to plus plus. So what do we have here? We have that the slope is 0 plus 3 is 3, -2 plus 2, -2 plus 2, that eliminates it, 0. And we should know that anytime you divide by 0 on a calculator, it says error. Now, why does it say error? Because it's undefined, okay? So right here, the answer is that it's undefined, okay? What does that mean visually? That you're rising 3 and you're running 0. So imagine that if you were on an XY plane, wherever you're at. Well, let's actually go to one of these coordinates, the coordinate -2, 0, -1, 2, 0. And if we were at this dot right here, and I rise 2 and I run 0, that means I don't go that way or that way, right? I go rise 2, run 0, I stay right there. Where's that line at? That's a totally vertical line. Okay, now when we're talking about slope, we're talking about steepness. Now, what does it mean that it's vertical? That means that it got so steep, it got undefined, all right? Anyways, again, we'll get to that later. Right now, just remember 3 over 0. Anytime 0 is underneath, it's undefined. I always say underneath, undefined. Undy, right? If 0 is underneath, it's undefined. Undy. Let's move on. And yet another question involving slope. Here's a slope formula. And we're going to plug in the values into the blank formula. And where am I going to get those values? From the coordinates xy, xy. This is my first point. This is my second point. So y2 is 0, y1 is -3, x2 is -2, x1 is +2. Simplify the fraction, plus plus becomes 3. Down here, a -2 and a -2 is a -4. So our slope is -3/4. Okay, that's our answer. Let's move on. Number 6, write the equation of the line that has the slope -2 and crosses the y-axis at -3. Okay, well, we first have to identify what they're asking. They are asking us to write an equation. And so far, we have reviewed two different forms of equations. We should remember the form y equals mx plus b. And we know that that's a slope-intercept form equation. And we also should remember point-slope form, which is y minus y1 equals m parenthesis x minus x1. And just to label these, this one's called slope-intercept. And why do we call this slope-intercept form? Because if it's in this form, if it's organized like this with y by itself equaling something x plus something, then the m is your slope and the b is your y-intercept, okay? And this one, if it's organized like this where you have y minus y1, then you have to identify the slope and the point. So the question is, what do they give us here? They give us the slope, which is -2, and they also give us technically a y-intercept of -3, okay, because they tell us that it crosses the y-axis at -3, and that's what a y-intercept is. So since they give us the slope and they give us the y-intercept, obviously we're going to use slope-intercept form, okay? So let's use slope-intercept form. That's y equals m. We said m was -2. We have x, and we also have plus b, and b happens to be -3. Okay, so that's your equation in slope-intercept form. However, if it is asking you to type it in, I recommend don't put the plus negative. Just write it in its simplest form, y equals -2x minus 3. Don't put plus -3. And again, when I ask you to type it in, the instructions should read type in with no spaces between your terms. So you're not going to put y space equals, you're just going to put y equals minus sign 2x minus sign 3, no spaces between your terms. Let's move on. On these next set of questions, we need to identify which equations produce parallel lines or perpendicular lines. So let's begin by defining or knowing the difference between parallel and perpendicular. First of all, parallel lines never intersect. They have the same slope. So if you're jotting down notes, you probably want to write down parallel have the same slope, the same m values, okay? Perpendicular lines, on the other hand, have negative reciprocal slopes, okay? Perpendicular lines have opposite reciprocal m values, okay? So it's all about the slope, it's all about the m. So in order to compare this equation with that equation and compare their m values, their slope values, well, you either have to have them in point-slope form or slope-intercept form. As you could see, neither of these are in point-slope or slope-intercept. So let's actually get them in slope-intercept form, which is getting y by itself. So on the first one, I'm going to subtract 2x, and you can't really subtract 2x from 12, so you're going to have to rewrite the whole thing. What's on the left side of the equal sign, the 3y? The equal sign comes down, and you can't really do 12 take away 2x, so I'm just going to rewrite it. However, I know I want y equals mx plus b, not b plus mx. So I want my x term first, so I'm going to simply write the minus 2x first, and then the positive 12 second. I'm almost done. I'm at my last step here. All I need to do is get rid of this multiplication of 3 in front of the y. So I am going to do the opposite of multiplying, which is dividing. What I do to one side, I do to the other entire side. So I'm going to divide by 3 here and divide by 3 here. This now gives us our slope-intercept form equation. Y equals, the slope is -2/3. Of course, you have an x. Instead of putting it on top, I put it to the side, and plus the b value, which in this case is 4, okay? So this is my slope-intercept form equation. I can now see my slope. I'm going to do the same for this one and see if I have the same slope or opposite reciprocal slopes or just totally different slopes. So the second equation, I need to get y by itself as well. That one's easy because I simply have 2 times y. To get rid of the multiplication of 2, I divide by 2. And what you do to one side, you do to the other entire side. So I divide everything by 2. What do I have now? I have my new equation. I'm going to write it down here. Y equals 3 divided by 2, you can't do it. That's a fraction, leave it. That's actually your slope. That's y equals mx and plus b, plus the b value. What is the b value? In this case, it's 5 halves. You could leave it 5 halves, or you could change it to what's half of $5? That's $2.50, 2.5. Either way, you don't really care about the b values. All you care about are the m values. So is this slope the same as this slope? The answer is no. Are they? So they're not parallel. So are they perpendicular? Are they opposite reciprocal slopes? Now, what do I mean by opposite? This is a negative. What's opposite of a negative? Positive. Okay, so far they are opposite. How about reciprocal? This 2/3, if you flip it, what'll it say? It'll say 3 halves. If you flip it, it'll say 2/3. So these truly are opposite reciprocal slopes. So fact number 7, classify them as perpendicular lines. Perpendicular. So select perpendicular and you'll get this question right. Let's move on to another one. Are these lines parallel, perpendicular, or neither? Again, you either need them in slope-intercept form, which is y equals mx plus b, or point slope form, which is y minus y1 equals m parentheses x minus x1. So if you have either of these forms, you could clearly see the m value. So this one is not in either of these, but it's almost like slope-intercept. All I have to do is get rid of that multiplication of -3. This is not y minus 3 where you add 3, guys, to get rid of the -3. There is no -3. What is this really? It's really a -3 times y. So you got to get rid of the multiplication of -3 by dividing by -3. And what you do to one side, do to the other entire side. So divide by -3 here, divide by -3 there, and you will have your equation in slope-intercept form. Y equals, now there is an invisible 1, technically an invisible -1, right in front of this x. Okay, that negative sign really means -1x. So my slope will be the -1 divided by the -3, and we do know that a negative divided by a negative is a positive, so I could at least change that slope to a 1/3. Now, of course, we still have the x with that slope, and the b value, a negative divided by a negative, is a positive, and 8/3, we're going to leave it as a fraction. Now, if I were graphing it, I would change it to 2 2/3. That way I know where it crosses the y-axis, a little bit more than 2.5. But anyways, all we really care about is finding the m, and we now know that the m value is 1/3. So let's find the other m value on this other equation. Is it y equals mx plus b? Absolutely not. Absolutely not. Could I change it to y equals mx plus b? Yes, I can. But before doing that, is it in point slope form? Yes, it is. As you could see, your x1, y1 values, your x1 values right here, and your y1 values right here, okay? And your m value is right here. So you don't have to do anything to it, okay? All we have to do is compare the slopes. So what slope do we have here? 1/3. What slope do we have there? 1/3. That means these lines are parallel, okay, because they're the same slope. Let's move on to another similar type of question. We have two equations. Oh, what happened here? Okay, I messed up. This should have a y equals right in front of there. My bad. We have these two equations, and we want to find out if they're parallel, perpendicular, or neither. This one already is in slope-intercept form. This one is not in slope-intercept form. So let's change that second equation into slope-intercept form by dividing by -2 to get rid of the multiplication of -2. And what you do to one side, you do to the other entire side. So divide everything by -2. So what do I have on the second equation? I have y equals the slope positive 3 halves. Why? Because a negative divided by a negative is a positive. And of course, you still have the x there. And for the y-intercept, I'm going to put minus, because a positive divided by a negative is a negative. So I'm going to put a minus. And you could change 15 into a decimal if you wanted to, or you could leave it 15 halves, or you could change it to a mixed number, which would be 7.5. But anyways, I'm just going to leave it as a decimal, 7.5. If I were graphing, I would go to the y-intercept of -7.5, and then from that point I would rise 3 and run 2. But I'm not graphing. All I'm doing is deciding whether these are parallel, perpendicular, or neither. And all I do is compare that slope with that slope. So are these the same slope? Are they the same, which makes them parallel? They are not the same. Are they opposite reciprocal slopes that make them perpendicular? They're not. This is positive, this is positive. So they're not opposite. Yes, they are reciprocals, 3/2, 2/3, 3/2, 2/3. They are reciprocals, but they're not opposite reciprocals, so they are not perpendicular. Right here we would say neither. Okay, I am going to end this video, and I want to start another because this video is getting too long. So we're going to divide it up into a couple of videos before we cover all questions. So we'll move on to the next question on the next video.